Hello there and welcome back to the Sleep Science, where you and I take the long, winding roads of the cosmos and turn them into lullabies for the restless mind. Tonight, your eyelids are already heavy as you picture yourself drifting, weightless between galaxies. On the horizon, if horizon even means anything in space, you see two spirals, radiant and majestic, creeping toward one another like dancers preparing for a waltz that will take billions of years to unfold. Their arms curl delicately, but their paths are inevitable. You know the punchline already. You probably won't survive this. Neither will Earth, at least not in its familiar form, if it's still hanging around in a few billion years. But that's fine. You came here for a sleepy stroll, not a survival guide. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, let me know where you're watching from and what time it is where you are. It's always fascinating to see how this little gathering of night owls and early risers stretches across the planet. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You float forward closer to those two galaxies, each a whirlpool of hundreds of billions of stars. They're not rushing at each other like bumper cars. It's more like an impossibly slow ballet. If you watched in real time, you might get bored before they so much as nudge. But sped up, the galaxies tilt, twist, and prepare to fold into each other, like ribbons of light intertwining. From this vantage, you can almost hear the hush of it, the low murmur of gravity doing its work. The Andromeda Galaxy, which you may have seen as a faint smudge through binoculars on a clear night, has been inching toward us for millions of years. It doesn't look threatening, just a blur in the sky, but astronomers, with their patient telescopes and patient math, know it's on a direct path to collide with the Milky Way. They predict the crash will begin in about 4.5 billion years. That's right about when the sun is starting to swell into a red giant, so frankly, humanity has bigger problems. But still, the thought of two galaxies kissing in the dark is a strangely romantic doom. As you glide between the spirals, you notice that the centers glow fiercely. There in the hearts of these galaxies lurk supermassive black holes, each with millions or billions of times the mass of the sun. They don't announce themselves loudly at first, just a quiet tug, a distortion, like the dance leaders waiting to step forward. You wonder for just a moment what happens when two of these beasts finally meet. That's a mystery for later in the journey, but the seed of unease is planted. Historically, people didn't even know galaxies existed as separate islands of stars until the 20th century. For most of human history, the Milky Way was thought to be the whole universe, a celestial river spilling across the night sky. It wasn't until Edwin Hubble in the 1920s peered at faint spirals and proved they lay far beyond our galaxy that the universe suddenly expanded, literally billions of times bigger than anyone had imagined. Historians still argue whether to call that moment the most important discovery in modern astronomy, or whether that title belongs to Copernicus, moving Earth out of the cosmic spotlight. And here's a quirky tidbit. Some ancient philosophers thought the Milky Way was caused by the sun's light reflecting off the atmosphere, like a celestial flashlight beam. Others suggested it was the residue of stars caught on fire, leaving behind glowing ashes smeared across the heavens. Imagine telling them, actually, it's billions of suns, and by the way, our whole galaxy is about to smack into another one. You'd be laughed out of the symposium, but you'd have the last laugh, though a very, very delayed one. As you drift through the void, you watch the galaxies tilt just a bit closer. At first it looks gentle, but you realize you're witnessing the opening act of an incomprehensibly long story. The arms, elegant spirals of dust and starlight, stretch toward each other like curious fingers. The darkness between them seems to tremble. You can almost imagine the hush of anticipation, as though the universe itself leans in to listen. The scale of it all presses down on you softly, like a weighted blanket. One galaxy contains on the order of 100 billion stars. Multiply that by 2, and you have a figure that doesn't even fit comfortably in your head. The human brain wasn't designed for such arithmetic. It short circuits on numbers that big. That's probably why this feels dreamlike. You can't hold it all at once, so you surrender to the sensation of being very, very small. And that smallness is strangely comforting. Your daily worries, emails, laundry, the awkward text you haven't replied to, dissolve into nothingness against the backdrop of a galactic collision. The galaxies don't care. They're too busy falling into each other, choreographed by gravity, patient beyond comprehension. Stars swirl, nebulae smear, dark lanes of dust stretch like brushstrokes across the spirals. The stage is set. The first tremors of the encounter ripple through the outer arms, tugging stars into long streams that look like pulled taffy. These are the tidal tales, though we'll wander into them in more detail soon. For now, you simply hover, bathed in the faint light of countless suns, watching the beginning of a cosmic embrace. And you smile, a little drowsily, because the best part is that this isn't science fiction. It's the slow reality of the universe. Gravity is the quiet instigator here, the patient director who doesn't rush the scene. You float on, feeling nothing of its pull, because gravity in space isn't like a magnet yanking you around. It's subtle, all-pervasive, and only reveals its drama when you step back far enough. From your perch, you can see the faint distortion beginning. The galaxies are no longer perfectly round spirals. Their outer edges, the wisps of stars and gas, begin to stretch like taffy under invisible fingers. It's hard to wrap your head around because you know gravity as the thing that keeps your socks glued to Earth, or the force that makes dropping your phone so catastrophic. Here, it operates on scales that make socks and phones absurd. A galaxy's gravity is the combined whisper of billions of stars, plus the hushed background presence of dark matter, which we'll talk about later. Each star, each cluster, each massive black hole contributes its part. Add them together, and suddenly whole galaxies are leaning toward one another. You notice how the closer they draw, the more the gravitational field shifts. If you could draw it on graph paper, it would look like two deep wells in a stretchy rubber sheet, sliding together until their rims blend. Somewhere in between lies a saddle point, a precarious balance, where the pull is equal in both directions. If you parked your imaginary spaceship there, it would be like standing on the top of a mountain ridge, leaning slightly one way or the other and tumbling down into a galactic valley. This isn't just theoretical fancy. In the 18th century, Isaac Newton proposed that the force pulling an apple to Earth was the very same one keeping the moon circling our planet. That idea, that one simple law governs both apples and galaxies, was so revolutionary that people literally couldn't sleep over it. Historians still argue whether Newton's Principia marked the birth of modern science, or whether that honor belongs to Galileo's stubborn insistence on rolling balls down inclined planes. Either way, it's nice to know your falling toast and colliding galaxies are cousins in the grand family of physics. But then there's a quirky sidestep. Long before Newton, some cultures thought gravity didn't exist at all, or at least not as a force. For example, Aristotle imagined that heavy objects simply had a desire to reach their natural place. Stones yearned for the ground, fire yearned for the heavens. By that logic, galaxies colliding would be like two actors moving together out of longing. Not bad for poetic imagery, even if the math is hopelessly wrong. You watch as the spirals grow restless. The stars near the edges begin to tilt inward. It's like spotting the first wobble in a spinning plate. You know more is coming. If you squint, you can almost trace invisible arrows showing how each star feels a tug, however faint, toward its neighbor galaxy. Those arrows crisscross and overlap until the whole scene looks like a web vibrating in slow motion. For planets caught inside this process, the changes are subtle at first. Suns remain loyal to their orbits, at least for millions of years, because the scale of distances is mind-boggling. Even though the galaxies are colliding, stars themselves are separated by so much empty space that direct crashes are rare. Imagine two swarms of bees colliding head-on, but the bees are separated by miles. They pass right through one another. The drama lies in the overall gravitational choreography, not the individual stings. Still, the pull grows stronger. You sense the galaxies straining, their arms reaching like long fingers, each reluctant to give up its elegant spiral pattern. For billions of years, gravity sculpted them into those forms. And now, with a patience that borders on cruelty, it begins to unmake them. There's a tension in that. You think about how humans try so hard to keep things the same, photographs, monuments, playlists on repeat. But galaxies, they shrug at permanence. Change is the rule and gravity is the agent of change. There's something oddly comforting about that too. If even galaxies can't keep their shape forever, maybe your messy kitchen doesn't need to be perfect either. One moment catches your sleepy attention. The centers of the galaxies flare brighter as their gravity fields start to blend. The stars near the core feel new pulls, wobbling slightly, their orbits becoming eccentric like dancers losing sync. It's messy, yet beautiful, an improvisation on the grandest scale. As you hover, you're reminded of a lesser-known historical curiosity. In the 1930s, astronomer Fritz Zwicky noticed that galaxies in clusters were moving too fast to be held together by visible matter alone. He proposed something invisible, Dunkelmaterei, or dark matter, was secretly weighing down the universe. At the time, people thought he was a bit eccentric. Historians still argue whether Zwicky was a misunderstood genius or just a prickly personality who happened to be right. Either way, his idea quietly sits here in the background, shaping this very collision. You exhale slowly, your mind softened by the scale. The galaxies drift closer still, and you know the first true fireworks are coming. But for now, gravity's pull remains a whisper, a lullaby of inevitability humming across light years. The galaxies creep closer still, and now their outlines no longer look like tidy spirals. The once symmetric arms are being teased and stretched by invisible fingers, drawn out into long, curving ribbons. These are the tidal tails, great arcs of stars and gas slung outward into space like cosmic streamers. They trail behind each galaxy as if the spirals were trying to keep their dignity, even while being pulled apart. You float above them, watching the first delicate wisps unravel, faint but undeniable. The name tidal tails is no accident. The same gravitational trick that moves Earth's oceans, the moon tugging water into bulges, plays out here, just scaled up beyond comprehension. As each galaxy pulls on the other's far side, material is stretched and thrown into space, forming trails that can extend hundreds of thousands of light years. If you could view them through a time-lapse spanning billions of years, the tails would whip and curl like smoke trails from a slow-motion firework. The most famous example you might recall is the Antennae galaxies, a pair about 45 million light-years away. Through a telescope, they look like two fuzzy blobs with bright centers, but long exposures reveal those glorious tails arcing outward like insect antennae. They are living proof of just how dramatic these galactic collisions can look. Historians still argue whether they should be considered one galaxy in the making, or two still fighting for their independence. Astronomers are romantics at heart, and sometimes their classifications sound more like relationship statuses. Here's a quirky tidbit to savor. One of the earliest people to sketch such distorted galaxies was William Herschel in the 18th century. Herschel, who also discovered Uranus and got to name it after a god of the sky talk about career flex, made careful drawings of curious nebulae that appeared stretched and elongated. He didn't know why, but he recorded the shapes faithfully. Imagine him peering through a hand-polished mirror in his backyard, while you drift through the very same structures in a kind of cosmic IMAX. From your position in space, the tails glow faintly, a mix of old stars dragged from the galaxy's edges and new stars sparking to life in the compressed gas. They look fragile, like strands of spider silk, yet they're vast enough to contain billions of suns. You reach out metaphorically, because reaching literally would be silly, and imagine brushing your hand along one of those arcs. It would take you millions of years just to stroll down a single tidal ribbon, yet it shimmers as delicately as morning frost. You imagine living on a planet caught in one of those tails. The night sky would be absurdly theatrical. One horizon would hold the glow of your own home galaxy's core, while the other would stretch into a starry highway leading nowhere. Entire constellations would shift over a single lifetime, drawn across the sky by the slow-motion tug-of-war. Astrologers would have a field day if they weren't too busy fainting at the sheer absurdity of it all. And yet, despite the drama, the stars themselves mostly glide past without touching. The tidal tails are not rivers of smashing suns, but graceful streams pulled by gravity's geometry. The danger is not in star-on-star violence, but in the rearrangement of orbits, the slow tugging that changes entire galactic neighborhoods. Picture your house being gently scooped up and placed hundreds of miles away, not by bulldozers, but by the shifting tides of space. That's the unsettling calm of it. The tails keep unfurling. They grow longer, curling outward in arcs that seem to beckon you. In the silence, you realize you're seeing history being written in real time, or rather, galactic history, which doesn't care about your human impatience. These tails will linger long after your species, your planet, maybe even your sun is gone. They are cosmic graffiti, drawn by galaxies in the act of colliding. Another historical note drifts through your thoughts. In the mid-20th century, astronomer Halton Arp made a catalog of peculiar galaxies, many of them with wild tidal tails. He believed these strange shapes held secrets about the nature of the universe itself. Some of his theories turned out to be wrong. He thought redshifts might not measure distance, for example, but his catalog is still a treasure trove of galactic oddities. Historians still argue whether Arp should be remembered more for his stubborn contrarian streak or for the beauty of the images he preserved. Either way, his tales live on. You drift closer to one particularly long streamer, and the silence makes you smile. It's like standing near an ocean tide pool, watching the water pull back in thin streams, except here the ocean is made of stars. The scale is almost comic, billions of suns behaving like droplets of water. You chuckle softly, thinking that the universe clearly doesn't believe in moderation. As the tails stretch further, the galaxies themselves grow more ragged, their spirals less defined. What was once tidy and iconic now looks messy, chaotic, alive. And that's the beauty of it. The tails aren't a sign of destruction, but of transformation. The galaxies are writing their new story in streams of starlight, and you're lucky enough to float here, eyelids heavy, watching the pen scratch across the cosmic page. You lean closer, if leaning is even possible in zero gravity, and realize something strange. Despite the violence of two galaxies colliding, individual stars almost never hit each other. It feels wrong, doesn't it? Billions of suns swirling together, arcs of starlight ripping across the void, yet the stars pass like ghosts. You half expect fiery explosions, dramatic crashes, the kind of spectacle Hollywood insists on, but space plays a subtler trick. The reason is scale. Stars are unimaginably tiny compared to the gulfs that separate them. If the sun were the size of a golf ball, the nearest star would sit hundreds of kilometers away. So when galaxies pass through one another, their stars are like two swarms of bees intermingling, but with so much empty space between each bee that collisions are practically non-existent. They glide by gracefully, barely noticing. That doesn't mean nothing happens, though. Gravity, once again, is the puppet master. The orbits of many stars get twisted, redirected, thrown into strange new patterns. A sun that once circled the center of its galaxy in a calm spiral might now find itself slingshot outward, hurled into a new orbit, or even ejected into intergalactic space. Picture moving into a new neighborhood not because you wanted to, but because the entire city got shuffled like a deck of cards. Astronomers call these displaced stars runaways. A few even end up racing through space alone, homeless wanderers cut loose from their galactic families. Somewhere out there in the infinite dark, solitary stars drift with no galaxy to call home. They shine just the same, though, lonely but unbothered, tiny nightlights in the cosmic wilderness. Historically, this realization, that stars don't smash together during galaxy mergers, wasn't obvious. Early astronomers peering at those fuzzy smudges imagined collisions more like billiard balls smashing. In the 19th century, Camille Flammarion, a French astronomer and enthusiastic storyteller, wrote vivid tales of cosmic cataclysms where stars themselves collided, showering sparks across the universe. Historians still argue whether Flammarion should be remembered as a visionary who inspired science, or as a sci-fi writer who blurred the lines of fact and fantasy. Either way, his imagery sticks in the mind. And then there's the quirky little fact. In 2008, astronomers spotted a star zipping through the Milky Way at nearly 2.5 million kilometers per hour. That's fast enough to leave our galaxy altogether. They believe it was catapulted by a gravitational encounter, maybe with the Milky Way's central black hole, maybe with another passing star. Either way, it's a tiny echo of the same processes at play in colliding galaxies, just writ small. Imagine being a planet around that star, watching your whole night sky tilt and shift as you're hurled into the void. Space road trip anyone. You glance back at the galactic scene, and it's oddly serene. The two spirals overlap now, arms tangled like dancers mid-spin. Yet there's no clattering crash, no sparks flying, just the silent shifting of stars into new formations. It feels more like clouds drifting through one another than solid objects colliding. Still, you notice something new. While the stars avoid direct impact, their gravitational fields interact. Whole clusters of stars tug on other clusters, subtly warping the structure of both galaxies. It's like two schools of fish swimming through one another. No fish collides, but the currents change, and the patterns ripple outward. And this dance happens slowly. You hover for what feels like hours, but in reality, this part of the merger takes hundreds of millions of years. If you were somehow a galactic citizen, you wouldn't notice the difference from one lifetime to the next. Constellations would shift, sure, but not with the drama you see here in Fast Forward. To you, though, it's all compressed, like a sleepy highlight reel designed for stargazers with limited patience. You can't help but laugh softly. Human beings complain when their Wi-Fi lags for 2 seconds. Galaxies, meanwhile, casually weave themselves into one another over eons, unfazed, unhurried. The contrast is cosmic comedy. Somewhere in the midst of all this, you wonder what Earth's descendants, if any, exist billions of years from now. We'll see. By then, the sun will be swollen, Earth may be charred, but perhaps some distant offshoot of humanity or another species will look up and see two galaxies blending overhead. To them, the stars will not feel lonely at all. The night will be so packed with glowing arcs and shifting clusters that the sky itself will look crowded, as though the universe finally decided to throw a party. You watch the stars glide past one another, unchanged but rearranged, and the silence wraps around you like a blanket. The universe, it turns out, is full of near misses, billions upon billions of them, woven into the fabric of galactic collisions. And maybe that's the real spectacle, not the explosions that never happen, but the delicate choreography of almosts. But if stars rarely collide, their more fragile companions, the great clouds of gas and dust, are another story entirely. You float deeper into the overlapping galaxies, and suddenly you see the fireworks begin. The gas clouds, unlike stars, are vast and fluffy, stretching for dozens or even hundreds of light years. When two of these clouds slam into each other during a galactic merger, they don't politely pass through. They compress, they heat, they collapse. And then they do something dramatic. They give birth to new stars in furious bursts. It's as though the galaxies, in colliding, have struck flint against steel. Sparks of starlight ignite all over, each one a sun being born in the chaos. You hover and watch as dense knots of gas glow brighter, their hydrogen collapsing under its own gravity until nuclear fusion ignites. Some regions sparkle with dozens of newborn stars at once, packed into glowing nurseries. Whole neighborhoods of the cosmos light up, like city blocks flickering on after a blackout. This star-making frenzy is known as a starburst, and galaxies in the throes of collision often glow brighter than ever before. For a few 100 million years, they become overachievers in stellar production. If galaxies had workaholic phases, this would be it, cranking out stars 10 or even 100 times faster than normal. Historically, astronomers first noticed starburst galaxies in the mid-20th century, puzzled by their unusually bright infrared glow. That warmth came from dust being heated by all the newborn stars hidden inside. One famous case is the galaxy M82, also called the Cigar Galaxy. It looks like a faint streak in the night sky, but radio and infrared observations reveal powerful winds of gas blasting out of it, evidence of a recent starburst. Historians still argue whether these outflows help create new stars elsewhere, or whether they quench star formation by blowing the fuel away. Even the cosmos can't decide whether multitasking works. And here's a quirky tidbit. In 2015, astronomers found a galaxy nicknamed Baby Boom that appears to have been producing stars at an absurd rate, up to 4,000 suns per year. Compare that with the Milky Way, which produces a measly 1 or 2 stars annually. Our galaxy is basically the laid-back uncle at the barbecue, while Baby Boom is juggling fireworks and shouting, "More stars, more stars." You drift closer to a collision site, where 2 gas clouds have just slammed together. The shockwaves ripple outward, compressing the surrounding medium. Tiny knots within the cloud condense, each one destined to become a star cluster. It's not silent here. You imagine, if you could translate the physics into sound, it would roar like an ocean surf, wave after wave of energy rolling through the interstellar medium. The reality is quieter, of course, but your brain fills the silence with the hum of creation. Planets, if they form around these newborn stars, will inherit a chaotic nursery. Radiation is fierce, stellar winds gust like hurricanes, and nearby supernovae will detonate before the planets even finish cooling. Not the friendliest neighborhood for life, unless you enjoy gamma-ray tanning beds. Still, out of this chaos comes enrichment. Heavy elements like carbon, oxygen, and iron, cooked in stars and flung outward, seeding the future with the building blocks of life. There's an odd comfort in realizing that Earth owes its existence to some ancient galactic chaos like this. Our sun was born from a cloud already enriched by generations of earlier stars. In other words, we're the children of collisions and explosions. You can almost imagine the universe winking at you. Messy beginnings, but look what they led to. The scene before you grows busier. Starburst regions shimmer like bonfires scattered across the galaxies. Nebulae, those glowing curtains of gas, shine in pinks and purples, lit by their newborn inhabitants. It's oddly festive, like galaxies throwing a fireworks display to celebrate their merger. You chuckle softly at the thought, maybe the universe is just showing off. And yet, even in all this brightness, there's a darker side. The frenzied star-making eventually burns through the available gas, leaving the galaxies depleted. They gorge themselves on starbirth until the pantry is bare. Millions of years later, the glow will fade and the galaxies will settle into quieter lives, their spiral arms smudged into amorphous shapes. The party, however dazzling, can't last forever. For now, though, you simply float and watch the spectacle. The galaxies collide not with crashes and fire, but with creativity, turning destruction into rebirth, stitching new stars into the tapestry of the cosmos. Your eyelids feel heavier as you take it in. The thought lingers. Even in the universe's roughest moments, beauty insists on showing up. You drift onward into the glittering aftermath, and the chaos suddenly feels organized. Those furious bursts of star formation you just witnessed don't remain scattered. Instead, they gather themselves into compact little neighborhoods, tight bundles of newborn suns bound together by their own gravity. These are the star clusters, the dazzling children of galactic collisions. Each cluster glows like a lantern hung in the dark. You can see hundreds, sometimes thousands, of hot young stars huddled together, burning blue-white, their light piercing through the dusty gas that birthed them. They sparkle so brightly that, if you lived on a nearby planet, though good luck surviving in such a radiation storm, your night sky would never grow dark. It would blaze like a perpetual festival of suns, each one close enough to cast shadows even at midnight. Sleep hygiene would be impossible. Clusters form because when gas clouds collide and compress, they don't just give birth to single stars. They spawn whole families, each sibling sharing the same cosmic cradle. Gravity then keeps them together, at least for a while, until time, and sometimes further galactic chaos, scatters them across the universe. It's a bit like humans gathering for a reunion, only to slowly drift apart as life carries them in different directions. Historically, star clusters have fascinated astronomers for centuries. The Pleiades, also called the Seven Sisters, are a nearby open cluster visible even to the naked eye. Ancient cultures wove myths around them, stories of sisters chased across the sky, or lost children of gods. Historians still argue whether those myths emerged independently in different cultures or spread along ancient trade routes. Either way, humanity noticed clusters long before anyone knew. They were snapshots of stellar family trees. And here's a quirky tidbit. In 2006, astronomers spotted a gigantic star cluster forming in the Antennae Galaxies, the same colliding pair we mentioned earlier. The cluster is so massive that, if it survives the chaos, it could evolve into a dwarf galaxy all its own. Imagine that, a galaxy born inside a galactic collision, like a cosmic matryoshka doll. You drift past one such young cluster glowing against a backdrop of dark nebulae. The stars here are newborn in cosmic terms, just a few million years old. They burn fiercely, burning through their fuel much faster than the sun ever will. Some of the most massive will explode as supernovae in mere millions of years, scattering heavy elements like confetti at a very loud party. Others, smaller and steadier, may survive for billions of years, perhaps nurturing planets and life long after the chaos of this collision has faded. The clusters aren't quiet places. Radiation blazes outward, stellar winds whip the surrounding gas into streamers and shockwaves, carving bubble-like cavities around the cluster. You can almost hear it, a low-frequency hum of energy and wind, like the deep rumble of an approaching storm. Yet in the vast silence of space, the effect is purely visual, a glowing bubble of stars pushing against the darkness. You notice how the clusters vary in size and shape. Some are loose and spread out, called open clusters. They're like friendly gatherings where stars come and go freely. Others are far more compact, with hundreds of thousands of stars crammed into a sphere just a few dozen light-years wide. These are the globular clusters, dazzlingly rich and ancient. Many globulars were born billions of years ago, relics of earlier collisions in the young universe. They still drift serenely around galaxies, reminders that chaos can leave behind order. Here, though, the clusters are fresh and wild. They feel like teenage stars at a galactic prom, loud, bright, burning energy too fast to last. You can almost imagine the galaxies rolling their eyes at their rowdy children, knowing that time will calm them eventually. It strikes you how resilient the universe is. Collisions tear galaxies apart, but in doing so, they create new pockets of light. Destruction and creation are not opposites here. They're the same process viewed from different angles. You let that thought settle into your mind like a lullaby. Endings are beginnings, beginnings are endings. Somewhere nearby, a particularly large cluster flickers brighter than the others. Maybe, you think, a massive star has just gone supernova, briefly outshining its siblings. You imagine the shockwave racing outward, rattling the cluster, stirring more gas, perhaps even sparking yet more star formation. Chaos feeding chaos, but also beauty feeding beauty. You linger, watching the clusters like candles scattered across the dark tablecloth of the galaxies. Each one will evolve, disperse, or endure in its own way. But for now, they shine together, blazing proof that even in the roughest collisions, the universe insists on making something beautiful. You drift closer to the centers of the colliding galaxies, where things take on a different kind of gravity, literally. Out here in the tidal tails and starburst regions, the story has been about clusters and fireworks. But down in the cores, there's a deeper, darker player making its move. Every large galaxy, including our Milky Way and Andromeda, shelters a supermassive black hole at its center. And when galaxies merge, these invisible giants begin a slow, inevitable approach toward one another. At first, you can't see them directly. Black holes hide their faces, swallowing even light. What you notice instead are the stars around them, their orbits beginning to wobble as two gravitational titans pull in slightly different directions. The central regions look unsettled, as though the galaxies themselves can't quite decide who's in charge. The black holes drift very slowly through the haze of stars, like heavyweight dancers circling before a duel. They move not because they want to, but because of dynamical friction, a fancy term for how their immense gravity stirs the stars around them, creating a drag effect that nudges them inward. Each step is millions of years long, but the direction is clear. Closer, closer, closer. Historically, astronomers suspected galaxies hid black holes long before we could prove it. In the 1960s, strange objects called quasars were discovered, blindingly bright beacons visible across billions of light years. They were eventually understood as supermassive black holes feasting on gas, their glowing accretion disks outshining entire galaxies. Historians still argue whether quasar research was the true beginning of black hole science, or whether the theory had been quietly maturing since Einstein's equations in 1915. Either way, the realization that these monsters lurked at galactic hearts changed everything. And here's a quirky tidbit for you. The black hole at the center of our Milky Way, Sagittarius A, is surprisingly well-behaved compared to the wild quasars of the early universe. It mostly naps, occasionally burping out a puff of X-rays. Scientists once described it as a cosmic sleeping dragon. Imagine telling medieval villagers that yes, dragons exist, but they just sit quietly, dozing at the center of galaxies until something disturbs them. Back in the merging galaxies before you, things are far from sleepy. Gas and dust swirl toward the central regions, funneling into the waiting black holes. Accretion disks ignite, glowing across X-ray and radio wavelengths. The black holes themselves don't shine, but the material spiraling into them heats up to millions of degrees, releasing enormous amounts of energy. To your sleepy eyes, the galactic cores look like lighthouses, beacons blazing out into the darkness. As the black holes inch closer, the galaxies around them continue to merge. Stars get shuffled, tails stretch further, clusters flare. But the ultimate drama is hidden in the center, two monsters on a collision course. They may orbit each other for millions of years, their dance tightening as they radiate away energy in the form of gravitational waves, ripples in spacetime itself. If you had the right kind of ears, tuned not to sound but to the fabric of reality, you'd hear them humming together, low and steady, like bass notes vibrating through the cosmic floorboards. Astronomers today are still waiting to detect such waves from supermassive black holes. LIGO, the famous observatory, has already captured gravitational waves from smaller black holes colliding, each event lasting just seconds. But when giants like these merge, the waves will be slower, deeper, stretching over years. Historians still argue whether our current instruments are sensitive enough, or whether we'll need a space-based detector like LISA, planned for the 2030s, to finally catch the whispers of these cosmic unions. You hover and watch the drama unfolding in slow motion. The black holes circle invisibly, while their surroundings flare with light. Gas clouds feed them, star clusters get tugged inward, entire regions are restructured by their gravitational appetite. They are like sculptors, carving the new galaxy from within, even before their final collision. And you can't help but smirk at the irony. Galaxies collide, stars are thrown about, clusters flare, but the true climax is a battle between two objects smaller than a solar system, hidden at the very heart. The universe has a flair for understatement. Your eyelids droop as you imagine that far-off future when these black holes finally meet. For a brief, glorious moment, they will release more energy than all the stars in their galaxy combined, not as light, but as ripples in spacetime itself. Somewhere, some advanced civilization, if it exists, might feel those tremors pass through their detectors, a faint shiver announcing that two galactic hearts have become one. For now, though, you float in the present, watching them drift, patient as only black holes can be. The galaxies swirl around them, unbothered, while the giants inch together in silence, like predators circling in tall grass. You blink slowly, adjusting to the dim haze of colliding galaxies, and suddenly you realize it isn't all serene drifting and quiet starbirth. Something more violent is happening here. Something you can almost feel in your chest if you let yourself imagine. When the great clouds of gas crash and the central black holes start feeding, the whole system begins to rumble with shockwaves and what can only be described as cosmic fireworks. It starts with the gas. When two massive clouds slam together, the compression doesn't just spark star formation, it also sends waves of energy rippling through the interstellar medium. These shockwaves sweep up dust, bend magnetic fields, and push matter into new knots. In your mind's ear, it's a deep rolling thunder, except the air is thin plasma stretched across hundreds of light years. You watch glowing arcs expand outward, bright curtains of ionized gas that look uncannily like auroras, if auroras had eaten an entire nebula for breakfast. Then there are the fireworks, jets of energy blasting out from the centers where black holes gorge on matter. The accretion disks blaze like cosmic whirlpools, and twin beams of radio energy shoot outward at near-light speed, drilling through the galaxies like lighthouses gone berserk. These are the famous relativistic jets, stretching sometimes millions of light years into intergalactic space. From a safe distance, they're beautiful. Up close, well, let's just say your sunscreen SPF 50 won't cut it. Historically, the discovery of such jets baffled astronomers. In the early 20th century, radio telescopes picked up strange lobes of energy extending far beyond visible galaxies. No one could quite explain how galaxies could produce such enormous, structured bursts. By the 1960s, it became clear they were tied to black holes, those hungry dragons we met earlier. Historians still argue whether the radio astronomers of that era realized the true scale of what they were seeing, or if they thought their equipment had gone haywire. And here's a quirky tidbit. In 2019, scientists captured the very first image of a black hole silhouette in the galaxy M87. What made it extra fun? That galaxy also has one of the most spectacular relativistic jets ever observed, stretching 5,000 light years. So not only did humanity glimpse the shadow of the dragon's mouth, but we also got to see the fire hose it's been spraying into space for eons. Back in your drifting perch, the galaxies look anything but peaceful now. Every region hums with energy, shockwaves racing, clusters blazing, jets roaring silently through the void. It's as if the galaxies, embarrassed by their initial slow-motion dance, suddenly remembered they were being watched and decided to put on a show. If you lived on a planet anywhere near these active regions, life would be tricky. Radiation storms would blast your skis, stellar winds would tear at atmospheres, and supernovae would pop off like cosmic popcorn. On the plus side, the night sky would be spectacular, always bright, always shifting, never boring. You'd probably never need fireworks festivals again, though your insurance premiums might skyrocket. The sheer scale of the shockwaves is staggering. Some sweep across thousands of light years, stirring gas that may not even form new stars for another 100 million years. It's the ultimate long-term chain reaction. You realize that what looks like chaos now is really the setup for the galaxy's future, seeding star systems, redistributing elements, sculpting the shape that will eventually emerge once the dust settles. Astronomers sometimes refer to this as feedback, the way black holes and supernovae talk back to their galaxies, shaping their growth. Too much energy blasted outward and star formation gets shut down. Gas is heated and blown away. Too little and galaxies might collapse under their own weight, birthing stars too quickly. The universe, you realize, is obsessed with balance, even when it looks like mayhem. You let the thought roll over you like one of those shockwaves. The energy of a collision doesn't simply destroy, it reorganizes. The fireworks aren't an ending, but a kind of punctuation, loud exclamation marks scattered across the script of cosmic history. Somewhere behind you, one jet flickers slightly, like a faulty flashlight in the dark. You smirk. Even galaxies have their clumsy moments. Maybe the jet ran into a stubborn gas cloud, or maybe the black hole had a hiccup mid-meal. The universe may be vast, but it's never too dignified for a bit of slapstick. The fireworks continue silently, vast arcs of light playing across the colliding galaxies, and your eyelids grow heavy again. The storm is fierce, but here in your floating seat, it all feels strangely calming, like listening to distant thunder from a cozy room, knowing you're safe. Amid the tidal tales, the starbursts, and the shockwaves, you suddenly wonder, what would it actually feel like to live on a planet inside a colliding galaxy? You close your eyes for a moment, imagining yourself standing in a backyard, or maybe on a balcony. Let's give you a good view, under skies utterly unlike Earth's. At first, the difference would be subtle. For generations, your ancestors would look up and notice constellations drifting out of shape. Familiar patterns, your Orion, your Big Dipper, would stretch into new forms as stars were tugged into fresh orbits. Slowly, a second spiral galaxy would grow brighter in the night sky, no longer a faint smudge but a glowing rival to the Milky Way. That would already be astonishing enough. But as the merger progressed, the sky would turn into a theater. Imagine stepping outside at night and seeing entire arcs of stars stretching like bridges across the heavens. One horizon glows with your home galaxy's core, while another burns with a luminous alien swirl pressing ever closer. It would be so bright that the concept of darkness might vanish. Street lamps, flashlights, totally unnecessary. You'd live beneath an eternal festival of light. The catch, of course, is survival. Life on planets near the busiest regions of colliding galaxies would face challenges. Radiation from starbursts and supernovae would pour across the sky, sometimes stripping atmospheres, sometimes sterilizing worlds. If your planet orbited a star near the galactic center, forget about gardening. Your crops would be flash-fried by X-rays before you finished watering them. Yet further out, in quieter neighborhoods, survival might still be possible. The galaxy is a big place, after all. Historically, humans once thought the heavens were fixed and eternal. For millennia, the stars were assumed to be immutable, tiny pinpricks set into a celestial dome. When Edmund Halley of comet fame noticed in 1718 that some stars had shifted slightly since the ancient Greeks recorded them, it was a shock. Historians still argue whether this realization, that stars move, was appreciated in its time, or if most people shrugged it off. Now, in a colliding galaxy, that truth would be impossible to ignore. The sky itself would seem restless, alive, constantly reconfiguring. And here's a quirky tidbit. There are stars called hypervelocity stars that have been flung across the universe at millions of kilometers per hour, often because of interactions during galactic mergers. If one of those zoomed across your sky, it wouldn't look like a shooting star. It would blaze for decades, sliding slowly but steadily across the heavens, a long goodbye written in light. From your balcony view, the night might sometimes become terrifying. Imagine looking up and seeing a nearby gas cloud ignite into a supernova nursery, glowing like a bruise across the heavens. Or waking to find that a relativistic jet now slices across the horizon, painting the atmosphere with radiation. It would be spectacular, but also a little like living next to a fireworks factory, thrilling until it goes off at the wrong time. Yet curiously, not all would be doom. Far from the galactic centers, on the quiet outskirts, life might go on peacefully. Your nights would be brighter, yes, your constellations ever-changing, but your daily life, cooking, sleeping, laughing at bad jokes, might continue without interruption. The human brain, master of adaptation, would simply fold this new cosmic reality into folklore. Children would point at the glowing arcs overhead and ask for bedtime stories about the galaxy bridge. It's comforting in a strange way. Collisions sound apocalyptic when you read about them, but for many stars, planets, and perhaps civilizations, they would be more spectacle than catastrophe. You'd simply grow up under skies that reminded you constantly that the universe is dynamic, restless, and beautiful in ways too vast to comprehend. You look up again in your imagination, eyes heavy now, and see the galaxies pressing closer, their arms braided across the heavens. Would you feel small? Maybe. But you'd also feel lucky. Not everyone gets front-row seats to the most majestic light show in the cosmos. Your drifting thoughts turn homeward now, because all this talk of fireworks and collisions isn't just abstract. Our Milky Way is on its own slow-motion course toward a cosmic embrace with our nearest large neighbor, the Andromeda Galaxy. You've probably seen it, though maybe without realizing. On a clear autumn night in the northern hemisphere, it's a faint oval smudge in the constellation Andromeda, visible even to the naked eye. That humble blur is 2.5 million light-years away, and it's headed straight for us at about 110 kilometers per second, which, if you're trying to convert that into commute time, is roughly, you'd still be late for work, but the galaxies don't care. The good news is, you don't have to worry about it. The collision won't begin for another 4 or 5 billion years. By then, the sun will be swelling into a red giant and Earth's oceans will have boiled away. So, yes, you probably won't survive this, but that doesn't mean it isn't worth picturing. The thought alone makes the universe feel grander, stranger, and maybe a little more intimate. Astronomers have modeled the whole affair with supercomputers, fast-forwarding billions of years like a cosmic time-lapse. The results are stunning. First, Andromeda grows brighter in our night sky, swelling from a faint smear into a vast disk stretching across the heavens. Then the two galaxies pass through each other once, twice, maybe 3 times, like two dancers circling before the final embrace. With each pass, tidal tails unfurl, stars get jostled into new orbits, and the galaxy's shapes grow ragged. Eventually, they merge into a single, larger elliptical galaxy that astronomers have already nicknamed Milkomeda. Yes, really. Astronomers may be brilliant with physics, but naming committees, a little less so. Historically, the idea that Andromeda was heading toward us is a fairly recent revelation. In 1912, American astronomer Vesto Melvin Slipher measured the motion of Andromeda using spectroscopy and discovered it was moving toward the Milky Way. That was unusual. Most galaxies are racing away, carried by the expansion of the universe. Historians still argue whether Slipher gets enough credit for this groundbreaking discovery, since Edwin Hubble often gets the spotlight. Either way, Slipher's work planted the seed of our galactic fate. And here's a quirky tidbit. If intelligent life still exists on Earth in 4 billion years, it may witness Andromeda so large in the sky that it would look brighter than the full moon, though spread across a much bigger area. Imagine backyard stargazing under skis where another galaxy looms so huge you could point out individual star clouds with the naked eye. No telescope required, just neck strength. You let the image settle in your mind. The Milky Way and Andromeda drawing together, their arms tangled, the night glowing brighter with every passing million years. For the sun, which by then will be an aging red orb, the timing is poetic. Its light will dim, but the sky will blaze with the combined glow of two galaxies merging overhead. Endings and beginnings, overlapping like verses in a cosmic lullaby. And as for us, maybe humanity will be long gone, or maybe some descendant species, artificial or biological, will still be around to watch. They won't call it doom, they'll call it home. You let your mind wander further into the future, imagining yourself standing under Earth's sky as Andromeda edges ever closer. It begins subtly, as all great changes do. Tonight, in your imagined scene, Andromeda is no longer a faint blur requiring squinting and patience. It has stretched, now clear and obvious, a pale oval hovering in the dark like a ghostly lantern. Over thousands of generations, it will grow larger, brighter, more detailed, like watching a painting slowly come into focus, but on a timescale that makes glaciers look speedy. By the time Andromeda fills the night sky, the view will be extraordinary. Its spiral arms will spread across constellations, drowning familiar patterns. Orion, gone, scattered like puzzle pieces. The Big Dipper, replaced with arcs of starlight glowing in a way your ancestors could never have dreamed. Astronomers today make computer simulations to predict this future view, and the results look like something out of a fantasy novel, except this fantasy is inevitable physics. Imagine standing in your backyard during those nights. One half of the horizon glows with the Milky Way stretching in its usual river of starlight, but opposite it, an entirely new galaxy rises, huge enough to span the width of your outstretched hand. At some point, the two galaxies overlap in the sky, stars upon stars upon stars, until the heavens are more crowded than empty. Nights will never again be dark. Sleep schedules will be a lost cause. Maybe that's why future humans evolve to nap constantly, because the universe refuses to turn off the lights. Historically, the changing sky has always fascinated us. Ancient civilizations used it as a calendar, a navigation tool, a cosmic storybook. Imagine how they'd react to a sky being rewritten in real time, constellations shifting not over thousands of years, but visibly over generations. Historians still argue whether humans today even notice subtle celestial changes, most of us too distracted by city lights or phone screens. But future descendants won't be able to ignore Andromeda's grand entrance. And here's a quirky tidbit. If Earth still has life when Andromeda arrives, the night sky might become so bright that some planets could have no true night at all. Think of a world where starlight is constant, where sleep happens only in caves or under artificial shades. Entire mythologies could be built around a sky that refuses to dim. Imagine bedtime stories beginning not with once upon a time, but with long ago when the night was dark. The first close pass will be both beautiful and unsettling. From Earth's surface, you would see Andromeda's bright core streaking across the heavens, its spiral arms weaving through our own. For a few million years, it will look as though two galaxies are braided into one colossal tapestry. Then, after drifting apart slightly, they'll swing back for another embrace, each pass reshaping the view. The drama won't be an instant collision but a long, drawn-out courtship. Your imagination adds little details. Lovers lying in fields pointing at glowing arcs, poets comparing galaxy bridges to stretched ribbons of silk, scientists frantically updating their star charts every decade, and parents telling children not to worry, that the sky has always been changing, just never this flamboyantly. And through it all, the sun will continue its slow march toward becoming a red giant, dimming Earth's habitability. Life, if it clings on, will face increasing challenges from its host star rather than the galaxies above. The irony is sharp. The greatest celestial spectacle of all time may unfold over Earth just as our world itself becomes inhospitable. Still, you smile softly at the thought. Beauty doesn't ask for permission, it simply arrives. And when Andromeda spreads across our skies, the heavens will remind anyone still watching that the universe is not static. It is restless, alive, and endlessly creative. You let your gaze drift away from the grand Milky Way, Andromeda courtship, and into stranger, more lopsided encounters. Not all galaxy mergers are even-handed waltzes between equals. Sometimes, it's less a dance and more a dinner. Astronomers call it galactic cannibalism, and it's exactly what it sounds like. A larger galaxy devours a smaller companion, shredding it into faint, ghostly streams. From your quiet seat in space, you can spot the evidence. Around many massive galaxies, faint arcs and shells shimmer in the dark, remnants of smaller galaxies that ventured too close and got torn apart. Their stars now drift along stretched-out paths, wrapping around the bigger galaxy like tattered scarves. It looks hauntingly beautiful, as though the cosmos keeps a scrapbook of everything it has eaten. The Milky Way itself is guilty of this gluttony. Even now, it's in the process of consuming the Sagittarius dwarf galaxy, a faint smudge of stars whose remains arc around us in loops. Over billions of years, those stars will be fully digested into our galactic halo, their original home erased. Historians still argue whether we should call the Milky Way a serene spiral or an insatiable predator. It depends on whether you admire its elegance or count its victims. A quirky tidbit. Some of the star streams left behind by devoured galaxies are visible even to amateur astronomers with modest telescopes. The Palomar Observatory Sky Survey in the mid-20th century first revealed these faint ripples around galaxies. To professionals, they were smoking guns, direct proof of cannibalism. To amateurs, they were just, hey, why does this galaxy look like it left its laundry hanging out? You float closer to one such galactic buffet. The larger spiral sits calm, glowing in the center, while the smaller companion has been stretched nearly to invisibility. Its stars are smeared into arcs, faint as chalk marks, circling the victor. If you were unlucky enough to live on a planet inside the doomed dwarf, you'd notice your sky warping in bizarre ways. Constellations would stretch, then vanish altogether as your galaxy's very shape was peeled apart. Eventually, your world's star would simply become one more immigrant, absorbed into the larger city of the Milky Way. This process isn't always a quick snack either. It can take billions of years for a dwarf galaxy to be fully digested. During that time, its stars might orbit in loops around the larger host, like crumbs swirling in soup before finally sinking. Some even leave multiple ghostly shells behind, concentric ripples like tree rings recording each pass. If galaxies could blush from embarrassment, these rings would be the evidence of sloppy eating. Historically, the first strong hints of galactic cannibalism came in the 1970s and 1980s, when sensitive photographic plates started showing shells and ripples around otherwise normal-looking ellipticals. Astronomers were stunned. Galaxies weren't the static, pristine structures once imagined, but messy eaters constantly reshaping themselves. Historians still argue whether this discovery marked a revolution in galactic astronomy, or simply confirmed what nature had been hinting at all along. Survival of the fittest is as true in the sky as it is on Earth. And yet, for all its violence, galactic cannibalism creates unexpected beauty. Those faint stellar streams are among the most delicate structures in the universe, ribbons of light that persist for billions of years. You imagine future astronomers, perhaps in galaxies far away, peering at our Milky Way and spotting these same ghostly arcs. To them, we'll look like we've been busy at the cosmic buffet. You can't help but chuckle softly. The Milky Way may one day merge grandly with Andromeda, but in the meantime, it snacks constantly. Dinner now, feast later. The universe, apparently, has the appetite of a teenager. You drift through the aftermath of cannibalism, expecting more ragged spirals and stretched-out tails, when suddenly you spot something stranger, something that looks less like a galaxy and more like a cosmic bullseye. A bright ring of stars circles a glowing center, thin and symmetrical, like ripples frozen in time. These are the ring galaxies, rare and mesmerizing, born from head-on collisions that are more target practice than tango. Picture this: a smaller galaxy barrels straight through the heart of a larger spiral. It doesn't stop there. It punches through, its gravity yanking the larger galaxy's gas and stars into an expanding wave. The result? A ring of bright, newly formed stars that rush outward, leaving a luminous circle glowing in the dark. You hover nearby, staring at one, and it looks uncannily like a halo hung in the void. The most famous example is the Cartwheel Galaxy, about 500 million light-years away. Its central hub glows faintly, surrounded by a bright outer ring and a few delicate spokes in between. Through a telescope, it looks like something sketched by a cosmic artist with a compass. Astronomers believe a smaller galaxy plowed through its middle not too long ago in galactic terms, setting off waves of star formation that still blaze across the ring. Historians still argue whether these collisions always produce such perfect circles, or whether we've simply been lucky to spot especially photogenic cases. Here's a quirky tidbit. Some ring galaxies don't just have one ring, but two, like celestial donuts stacked on top of each other. They're sometimes nicknamed double rings, though you'd think astronomers could have come up with something snappier. Imagine living in such a galaxy. Your night sky wouldn't just have constellations, it would have glowing loops arcing across the heavens, shifting as the ring expanded outward. You let yourself imagine it. Standing on a balcony, or maybe just floating in space, you'd see the sky transformed into a pattern that no mythmaker could ignore. A vast circle of starlight would dominate the heavens, so symmetrical that it would surely inspire stories of gods and celestial eyes watching from above. Humanity invented constellations out of scattered dots. Give them a giant glowing ring, and they'd never stop talking about it. The physics of these rings is as fascinating as the beauty. When the smaller galaxy plunges through, it creates density waves in the disk of the larger one. Gas clouds collapse in these waves, igniting furious bursts of star formation along the ring. The process is a bit like tossing a pebble into water and watching the ripples spread outward, except the ripples here are tens of thousands of light years wide, and the splash lasts hundreds of millions of years. Historically, astronomers didn't know what to make of ring galaxies at first. When the cartwheel was photographed in the mid-20th century, some thought it might be an illusion caused by dust obscuring parts of a spiral. Others speculated it was a galaxy mid-explosion. Only later did simulations confirm the head-on collision scenario. Historians still argue whether the cartwheel is the most striking example of galactic collisions, or whether other oddities, like the antennae or whirlpool, deserve that crown. As you watch the ring expand, you notice faint traces of the intruder galaxy still drifting nearby, a smaller companion looking oddly innocent after wreaking so much havoc, like someone crashing through a door, leaving chaos behind, then shrugging and wandering off. The larger galaxy will spend eons reshaping itself, but the memory of the impact will linger in the circle of stars for ages to come. You chuckle softly, eyelids heavy, realizing the universe has a sense of humor. Most galactic collisions look messy, tangled, and chaotic. And yet, every once in a while, nature produces a perfect circle, geometry written in light. A reminder that amid the chaos, symmetry sometimes sneaks in, uninvited but welcome. You drift onward from the delicate geometry of ring galaxies and find yourself staring at something far less graceful, yet strangely majestic. The tidy spirals with their elegant arms and bright starry lanes are gone. In their place sits a swollen oval of stars, glowing softly like a cosmic puffball. This is what happens when spirals merge. Their graceful arms get smeared away, and the end product is a giant elliptical galaxy. From afar, an elliptical looks calm, even boring. No sweeping spiral arms, no delicate structures, just a big glowing egg of stars. But up close, you realize it's the ultimate survivor. Spirals are fragile. Their shapes depend on orderly rotation and relatively undisturbed disks. Smack two of them together, and those disks are ruined. Gravity scrambles the orbits of billions of stars, shuffling them into random directions until the entire system settles into a rounded blob. The old dance patterns are forgotten. Everyone just mills about. Astronomers believe this is the eventual fate of our Milky Way and Andromeda. Billions of years from now, the delicate arms of both will vanish, replaced by one enormous elliptical sometimes nicknamed Milkomeda. Romantic? Maybe not. Accurate? Absolutely. If you could somehow visit it, the galaxy would glow with billions of stars packed close together, a city of light with no defined streets. Historically, elliptical galaxies puzzled astronomers. In 1926, Edwin Hubble created his famous classification scheme, the Hubble tuning fork, which organized galaxies into spirals, barred spirals, and ellipticals. For decades, ellipticals were thought to be primordial fossils, galaxies that formed early in the universe and just sat there doing nothing. But by the late 20th century, simulations showed otherwise. Ellipticals are often the children of mergers, not ancient relics. Historians still argue whether Hubble himself suspected this, or if he truly believed ellipticals were the universe's elder statesmen. And here's a quirky tidbit. Not all ellipticals are round. Some are stretched into football shapes, others are more lumpy than smooth. Astronomers, in their usual poetic flair, classify them from E0, nearly spherical, to E7, strongly elongated. It's basically a cosmic egg rating system. Imagine grading breakfast by eccentricity, scrambled eggs as E0, omelets as E7. Back in your drifting perspective, the transformation feels almost melancholy. The spiral arms, once graceful highways of starlight, are gone, but the elliptical is not lifeless. In fact, it glows with a steady brilliance. Most of its stars are older, redder, quieter than the hot blue bobbies born during the collision. Star formation has slowed. The galaxy has burned through much of its gas. It's not a bustling nursery anymore. It's more like a retirement community, glowing gently with the light of elder suns. If you lived inside such a galaxy, your night skis would be crowded with stars. They'd be closer together than in a spiral, filling the heavens with light. Darkness would be rare. You'd never run out of inspiration for myths and poetry, though you might miss the dramatic shapes spirals offered. Ellipticals trade flair for density, grace for solidity. They're galaxies that have settled down. And yet you can't help but admire them. They're massive, some containing trillions of stars, dominating galaxy clusters with their sheer bulk. They are the sum of countless past collisions, each merger adding to their size. To float here in the middle of one is to float in a graveyard of galactic history, a reminder that every elegant spiral eventually grows up, collides, and becomes something less flashy but more enduring. You smile drowsily at the thought. Spirals are the galaxies of youth, energetic and expressive. Ellipticals are galaxies of age, calm and stately. Both have their beauty, and the universe, patient as ever, makes sure we get to see both sides of the story. You hover quietly inside the hazy glow of an elliptical and something catches your eye. Sudden flares, like cosmic flashbulbs going off in the distance. Not all the new stars born in the chaos of a merger live long. The biggest among them, blue giants many times the mass of the sun, burn hot and fast, exhausting their fuel in just a few million years. And when they reach the end, they don't slip gently into the night. They go out in roaring detonations called supernovae. The collisions of galaxies, with all their gas cloud compressions and starbursts, breed these short-lived giants in abundance. And so, as the galaxies merge, supernovae erupt more frequently than in calmer times. You watch one now. A blue star in the distance suddenly brightens, swelling into brilliance. For a brief moment, it outshines billions of stars around it. Then, with a violent exhale, it scatters its guts into space. Calcium, iron, carbon, oxygen. All the heavy elements that will seed the next generation of stars and planets. If you could stand on a nearby world, hopefully with a really good sunscreen, it would be both beautiful and terrifying. The explosion would blaze so bright it could be visible in daylight, casting shadows at night like a second sun. The radiation would strip atmospheres bare if you were too close, sterilizing planets in an instant. Yet without these destructive deaths, you and I wouldn't exist at all. The iron in your blood, the calcium in your teeth, the oxygen in your lungs, all were forged in the hearts of stars and scattered by supernovae long before Earth was born. You are, quite literally, the ashes of stellar chaos. Historically, humanity has recorded supernovae for centuries. Ancient Chinese astronomers documented a guest star in 1054 CE that shone brightly for weeks before fatting. Its remnant is the Crab Nebula, still glowing today as a tangled web of gas. Historians still argue whether European observers also noticed it but failed to write it down, perhaps because it didn't fit the tidy worldview of the heavens as unchanging. Imagine ignoring one of the brightest explosions in the sky because it didn't suit your philosophical mood. And here's a quirky tidbit. When a nearby star goes supernova, it can sometimes leave behind a neutron star, an object so dense that a teaspoon of its matter would weigh about as much as Mount Everest. These tiny corpses spin rapidly, beaming out pulses of radio waves like cosmic lighthouses. Astronomers call them pulsars, though I can't help but think space metronomes would have been catchier. In merging galaxies, the chaos amplifies these events. Supernovae erupt across starburst regions, sending shockwaves rippling through already turbulent gas. Each explosion stirs up its surroundings, sometimes triggering yet more star formation, sometimes blowing holes through nebulae. The galaxies aren't just colliding, they're baking the ingredients for future worlds, scattering elements like flour across a cosmic kitchen counter. You drift through the aftermath of one such blast. The nebula expands in a glowing bubble, colors shimmering: pink hydrogen, green oxygen, golden sulfur. It looks delicate, like watercolor paint bleeding into paper, yet it carries the force to reshape everything nearby. In a few million years, this bubble will mix with its surroundings, enriching the interstellar medium. Someday, those elements might settle into a new star, a new planet, maybe even a creature staring at its sky and wondering how it all began. It's a sleepy, comforting thought. Collisions look like destruction, but in truth, they're recycling projects on a galactic scale. Stars die, galaxies merge, but out of that chaos comes the possibility of life. You tuck that thought away like a blanket. Every ending carries the seed of another beginning. You drift deeper into the merged galaxies, letting the bright afterglow of supernovae fade, and soon notice something strange. For all the drama, tidal tales, starbursts, jets, and explosions, there's an invisible hand guiding everything. You can't see it, but you feel its presence in the way the galaxies bend and merge. This is dark matter, the silent architect of collisions. Dark matter doesn't glow. It doesn't shine or scatter light. You couldn't scoop it up, couldn't hold it in your hand, couldn't even photograph it. Yet it outweighs all the stars, gas, and dust combined. Every galaxy sits inside a vast halo of this invisible stuff, and when galaxies collide, it's these halos that pass through one another first, steering the outcome like invisible bumpers in a cosmic pinball game. Without dark matter, galaxies wouldn't even exist. The visible matter, stars and gas, doesn't have enough mass to hold a galaxy together. The spirals would unravel, the stars flying off into intergalactic space. But wrapped in their halos of dark matter, galaxies are bound tight. And when they merge, the halos overlap, mingle, and gradually settle into a new, larger halo, dictating how the galaxies inside will evolve. Historically, the idea of dark matter began almost by accident. In the 1930s, astronomer Fritz Zwicky noticed that galaxies in the Coma cluster were moving too fast to be held together by visible matter alone. He proposed some Dunkelmaterei, dark matter, must be there, providing hidden gravity. Most of his peers ignored him at the time. Historians still argue whether Zwicky was dismissed because his idea was too radical, or because he was famously irritable and hard to work with. Possibly both. And here's a quirky tidbit. In 2006, astronomers observed a system called the Bullet Cluster, where two galaxy clusters had collided. The visible gas from the galaxies slammed together and slowed down, glowing in X-rays. But the bulk of the mass, mapped by gravitational lensing, sailed straight through, barely interacting. It was a rare, almost direct photograph of dark matter's ghostly presence, like catching footprints in snow with no walker in sight. As you hover now, you imagine dark matter as a kind of invisible ocean, with galaxies as luminous ships bobbing on its surface. When two ships collide, the waves beneath them determine where they drift. You can't see the water, but you know it's there because the ships wouldn't float without it. The galaxies, stars, and gas are just the glittering foam. The real bulk lies beneath. The mystery of dark matter remains unsolved. Is it made of undiscovered particles? WIMPs, axions, sterile neutrinos, names that sound more like Pokemon than physics? Or is it something else entirely, a flaw in our understanding of gravity? Historians still argue whether the concept itself will survive or whether future astronomers will laugh at our invisible scaffolding idea the way we now chuckle at Aristotle's natural place for falling stones. Yet even if we don't know what it is, we know what it does. In this galactic collision before you, dark matter keeps the show running smoothly. It prevents stars from flying apart like sparks, shapes the halos that eventually settle into equilibrium, and ensures the merged galaxy doesn't dissolve into chaos. It is the quiet backbone, the silent majority, the uncredited stagehand of the cosmic theater. You close your eyes for a moment, picturing it. A vast halo surrounding every galaxy, invisible but essential, a kind of gravitational cocoon. And when galaxies collide, the cocoons pass through each other, merging and reshaping the galaxies within. It's oddly comforting to know that even in chaos, there's structure, an unseen safety net holding the universe together. The scene around you slows. After all the bursts of light, the jets, the explosions, you realize this collision isn't a quick spectacle. It's a story written on timescales so vast they make mountains look impatient. Galactic mergers are slow dances, unfolding not over years or centuries but billions of years. From your vantage point, you've been watching a time lapse, compressing eons into minutes. But if you actually lived inside this process, you might never notice it happening at all. Think about it. Galaxies typically take hundreds of millions of years just to complete a single pass through one another. They can swing together 2, 3, or even 4 times before finally coalescing into one. To put that into perspective, a few 100 million years ago on Earth, dinosaurs were the latest big thing, and the continents didn't even look the way they do today. The entire rise and fall of species, civilizations, maybe even planets, can happen during just one act of the galactic waltz. The thought makes you chuckle softly. Humans get impatient when they're streaming video buffers for 5 seconds. Galaxies, meanwhile, are fine with cliffhangers lasting eons. They play the longest game of will they, won't they, in the cosmos. Historically, even astronomers struggled to comprehend these timescales. In the 18th century, some still believed the universe was only a few thousand years old. The idea of processes taking billions of years was almost unthinkable. Only in the 19th and 20th centuries, with advances in geology and astronomy, did scientists start to accept deep time. Historians still argue whether Charles Lyell's geological uniformitarianism or Darwin's evolutionary theory did more to cement the idea of vast timescales in science. Either way, once you grasp deep time, galaxies suddenly make more sense. And here's a quirky tidbit. If you could somehow watch a galactic collision in real time, it would be one of the most boring shows in existence. You could stare for your entire lifetime and not see much change. Astronomers rely on simulations and snapshots of many galaxies at different stages to piece the story together. It's a bit like trying to understand how trees grow by looking at a forest once a day and comparing the tallest to the shortest. The trick is imagination and a lot of patience. You let yourself imagine being a being who lives as long as galaxies. For you, the dance wouldn't feel slow. It would feel graceful, perfectly paced. You'd watch arms stretch, tails unfurl, stars scatter, clusters ignite, and black holes drift together, all without hurry. Perhaps time itself feels different at that scale. Where humans count minutes, galaxies count epochs. There's also a calming realization. If mergers unfold so slowly, then the universe isn't in a rush. All the drama, all the chaos, it still takes billions of years to resolve. That slowness is its own lullaby. You can almost feel yourself sinking to the rhythm of the cosmos, heartbeat slowing, breaths lengthening, as though your body is learning from galaxies how to relax. The patience of the universe also reassures you. Whatever worries press on your mind, deadlines, errands, awkward conversations, suddenly feel comically brief. Galaxies collide, reshape, and settle, all while stars are born and die, while civilizations rise and fall. Against that backdrop, your to-do list seems less like a crisis and more like a momentary ripple. You linger in that thought, eyelids heavy, watching the galaxies drift closer to their final embrace. The slow dance continues, patient, inevitable, endlessly beautiful. The long, slow dance continues until, at last, the storm begins to quiet. You notice it first in the tidal tails, those long streamers of stars once flung out like ribbons. They begin to fade, their arcs dispersing into the wider halo of the merged system. The furious starbursts calm as the gas supply dwindles. The fireworks of supernovae grow less frequent. The new galaxy, starts to look less like two rivals locked in chaos and more like one settled being. This is what remains after the storm. You drift back, taking in the whole picture. Where once two distinct spirals tangled together, there is now a single, rounded form. Its shape isn't as flashy as those pinwheel spirals, but it glows with a steady, golden light. The hot blue stars born during the starburst are fading, leaving behind older, redder suns. The galaxy's youth has passed. What you see now is maturity, calm, luminous, enduring. Historically, astronomers used to assume galaxies looked the same across time. They thought ellipticals, spirals, and irregulars were permanent categories, as fixed as animal species. Only with the rise of galactic simulations in the late 20th century did it become clear: galaxies evolve. Collisions transform spirals into ellipticals. Cannibalism reshapes clusters. The universe is a place of constant change. Historians still argue whether Edwin Hubble, who created that famous tuning fork diagram, secretly suspected this, or whether he truly believed his categories were eternal. Here's a quirky tidbit. Some galaxies show what astronomers call fossil shells, faint, ghostly ripples around their edges, leftovers from past collisions. They're like scars, subtle but telling. If you lived inside one of these galaxies, you might not even notice them, but from afar, they're whispers of battles long past. The galaxy you're floating near now has just such scars, arcs of stars faintly glimmering at its outskirts, traces of the violence it endured. Life, if it exists inside this merged galaxy, would now find a calmer home. The wild bursts of radiation have subsided, the relativistic jets have dimmed, and the frequency of nearby supernovae has declined. The night sky would still be full of stars, but more orderly, more predictable. Civilizations here could look up and see stability, unaware of the eons of chaos that forged their peaceful backdrop. You drift closer to the heart of the galaxy, where the two central black holes have finally merged. Their union has left a ripple in space-time, gravitational waves echoing outward long after the fact. The merged black hole sits now in the center, larger than either parent, quietly holding the galaxy together. Around it, stars orbit calmly, as if the storm had never happened. There's something oddly reassuring in this sight. The universe doesn't stay in chaos forever. It stirs itself into a frenzy, yes, but then it settles again, as though even galaxies need rest. You breathe a little easier, realizing that destruction and order are two phases of the same cycle. If you tilt your view outward, you see the new galaxy glowing steadily in the darkness of intergalactic space. It isn't alone, of course. Galaxies rarely are. Perhaps smaller companions still orbit nearby, future snacks waiting to be digested. But the main event, the grand collision, has passed. Now begins the long, slow life of an elliptical, aging gracefully for billions of years. You smile faintly, eyelids heavy. The storm may have raged for eons, but in the end, calm always returns. The galaxies remind you that change is not only inevitable, it is survivable. You drift further outward now, leaving behind the calm glow of one newly formed elliptical, and suddenly the scale expands again. Because galaxies don't just collide in pairs. Sometimes, entire clusters of galaxies smash together, weaving themselves into structures so colossal they defy imagination. If two spirals merging felt like a dance, this is more like a stampede. Hundreds or even thousands of galaxies plunging together, wrapped in halos of dark matter, drowning in seas of hot gas. The scene looks almost painterly from your vantage. Dozens of bright ovals, spirals, and smudges stream toward one another, their shapes distorted by gravity. The space between them glows faintly, not from stars, but from X-ray, emitting gas heated to tens of millions of degrees. It stretches across millions of light years like a shimmering fog. To drift here is to float inside a furnace that somehow looks delicate, as though fire and silk had been braided together. One famous example is the Bullet Cluster, two galaxy clusters that collided about 150 million years ago. It became one of the most important pieces of evidence for dark matter, because the visible gas clouds slammed into each other and slowed down, but the bulk of the mass, mapped by gravitational lensing, kept on going. Historians still argue whether that discovery alone sealed the case for dark matter, or whether it was simply the most dramatic proof among many. Either way, the Bullet Cluster is the poster child for cosmic pileups. And here's a quirky tidbit. Galaxy clusters sometimes produce what astronomers call radio relics and radio halos, enormous arcs and patches of radio emission stretching across millions of light years. These are thought to be shockwaves from cluster mergers, like sonic booms frozen into the fabric of space. Imagine looking up at your night sky and seeing faint glowing arcs larger than the moon, slowly fading as the cluster settled down. That's the sort of graffiti left behind when clusters collide. From your sleepy perspective, the scale feels almost absurd. One galaxy has hundreds of billions of stars. A cluster contains hundreds or thousands of galaxies. And yet, they too are just pieces of an even bigger puzzle. Superclusters, webs of galaxies spanning hundreds of millions of light years, all connected by the filaments of the cosmic web. You're reminded again that no matter how big you think the universe is, it has another trick up its sleeve. Life inside a colliding cluster would be complicated. If your planet orbited a star near the cluster core, you'd be surrounded by galaxies so close they'd light the sky like permanent fireworks. Radiation from the hot gas could be dangerous, and gravitational tides might sling galaxies around like toys. But at the same time, imagine the inspiration of such a view, an entire sky filled not just with stars, but with galaxies glowing like lanterns. The collisions between clusters are messy, chaotic, violent, and yet productive. They stir up gas that may later cool into new stars. They blend dark matter halos into larger scaffolds. They transform the identities of galaxies, feeding ellipticals and dispersing dwarfs. On a grand scale, they're the engines that build the largest structures in the universe. You let yourself smile. Even at this monstrous scale, the story is the same. Collisions lead to transformation. The universe doesn't break things just to break them. It remakes them endlessly into new forms. Galaxies merge into clusters, clusters into superclusters, and somewhere down the line, perhaps even greater patterns emerge, ones we can't yet see. From here, drifting among dozens of colliding galaxies, it feels like you're looking not at chaos but at weaving, threads crossing threads until a tapestry forms. The fabric of the cosmos is never static. It pulls, knots, and stretches, always in motion, always becoming. Your eyelids flutter heavy. The noise of colliding clusters fades into silence, and all you see is the vast, soft glow of countless galaxies, merging, settling, repeating. You float further still, pulling back until even colliding clusters shrink into glowing knots along invisible threads. The scale is overwhelming. Galaxies that once felt immense are now just beads on strings of light, strung across the cosmic web. The universe stretches on without edge, each strand buzzing faintly with collisions in progress, each knot glowing with the memory of mergers already past. It feels infinite, and maybe it is. From this height, you see the pattern. Galaxies collide, merge, calm, and then collide again. Clusters slam together, then drift quietly until the next partner wanders close. It's a cycle written into the bones of the universe. Chaos giving way to order, order feeding back into chaos, over and over. There is no final state, just transformation. You think of our own Milky Way, waiting patiently for its rendezvous with Andromeda. You think of the stars already being scattered by tidal streams, of the dwarf galaxies being eaten even now. And you think of the far future when Andromeda will glow steady and calm, its past written only in faint scars of starlight. Your tiny human lifetime sits like a whisper inside that story. And yet somehow, knowing the ending makes the present more precious. Historically, humanity has always wrestled with infinity. Ancient philosophers argued whether the cosmos had a beginning or whether it stretched forever. Some imagined infinite worlds, each with its own sun and planets. Historians still argue whether those early speculations count as science or poetry, but either way, they show something universal. People have always tried to place themselves inside the endless. You're doing the same now, drifting in your imagination, trying to hold infinity in your palm. And here's a quirky tidbit. The word galaxy comes from the Greek Galaxies kyklos, meaning milky circle, inspired by our own Milky Way. Imagine telling those ancient stargazers that their Milky Circle was just one of trillions, all colliding, merging, and reshaping across eternity. They would have either laughed or written epics even grander than the ones they left behind. As you float now, the imagery softens. The collisions blur into ripples, the galaxies into gentle glows. Infinity stretches in every direction, but it no longer feels frightening. It feels quiet, steady, reassuring. The universe is vast, yes, but it is also patterned. Even its wildest storms resolve into calm. You breathe deeply, eyelids heavy, and let yourself sink into that pattern. Stars are born, stars die, galaxies collide, galaxies merge, and through it all, light continues to shine. You don't need to solve infinity. You only need to rest inside it. The galaxies fade from view, their arcs of starlight dissolving into a soft, endless dark. The noise of collisions, the fireworks of supernovae, the hiss of jets, all grow quiet, like distant waves fatting on the shore. You are left with silence, a silence so wide it feels like it could hold you safely forever. The universe slows its packing for you now. Every star drifts a little farther away, every glow dims to a gentle shimmer, until what surrounds you is nothing but calm. It is not empty, though. There's always light, always presence, but the light has softened into a lullaby. The galaxies, their collisions, their stories, continue somewhere out there, but they no longer demand your attention. They are content to go on without you. You let your breathing follow the rhythm of deep time, slow and patient. Each inhale stretches like a million years. Each exhale feels like a galaxy settling into peace. Your body grows heavier, your thoughts lighter, until you are floating, almost transparent among the quiet stars. If your mind wanders, let it drift with the galaxies, spinning, colliding, merging, but always finding rest again. You don't need to hold on to anything. The universe itself is holding you. And as your eyelids close at last, the final image is gentle. A soft glow, a quiet hum, and the knowledge that infinity rolls on, shaping itself endlessly, while you, for now, get to rest.